All right, this is part 2. I showed you why thermostats will likely go blank in the previous video, so go check that out. I do a demo with the float switch. A lot of reasons can cause the float switch to receive water instead of the main drain. Damage to the drain, the blower stops blowing, or low refrigerant situations, then the coil will freeze up and then rapid thaw, or it thaws a little too fast, obviously, to drain out properly, or your drain is clogged, and then this situation could happen, and you literally could have all the above. There's a few other reasons this will happen. You could have a frog in the drain line outside. It could be all kind of weird things. But having a professional come out and take a look at it, don't get in there and mess with all the wires. So now we're going to turn this thermostat on, and I'm going to show you how this gets interrupted. This would be powering the outside, okay? We got our 24 volts coming from the transformer, and the 110 is hooked up here, but that's not going to be that way. It's going to be 240, so it's very dangerous. Be careful, and don't mess with any of this stuff on your own. So I've got my transformer getting 110, and it's pumping 24 volts here. I'm breaking this red wire that's going to the thermostat, and so if there's a problem and it detects water, and it doesn't always work, sometimes you got a dirty pan inside the air handler, and the water will come off the edges, or if the coil's dirty, it can drip straight down. So that's not good. So we'll turn this on, and as I turn that on, this will turn on, and that would be simulating bringing the outside unit on. So I want to bring this temperature down below the set point, and then wait a second. This will pop in. Perfect. So now this contactor's pulled in. If there's any reason for this contact, anything that breaks the contact of the 24 volt wires that are going into this, then you might still have a thermostat. It might still be blowing inside, but you don't have your compressor. And the compressor terminal, that's a whole nother story there. If you have water, or if you don't have water in this, okay, you could still lose your 24 volts here. Now, this would just be an indication that was hardwired properly, and we're not using batteries. In the previous video, I let you know, hey, we don't really use batteries on these installs nowadays, so what we do is we hardwire the red and the common wire, which is the blue is the common here in this instance, and it's usually that way, and then the red is going to be your other wire that is going to connect the power. Now here's where it gets a little more interesting. The coil that is behind here, which is that copper wound coil, if it degrades or lightning strikes it, you've got little burn marks on that, then you won't get enough 24V to pull the coil in. You may still have 24V here, but that still is not going to work. If you get ants behind the little brass points here, then that will also be a problem. If it's burnt, that will also create a problem. Sometimes even for high voltage, you'll pull this in just fine, but the contact points are degraded so badly. Let me grab something here I can point with and not die. These contact points, because you'll have line side, okay, where power's coming in. You got 240 volts coming in. You got 120, 120. And then up here, you may check across this and not really get a reading. Individually, you'll check it and you'll get like 118, 120, but across it you won't, because you're losing voltage. You're dropping off right here. And these contactors, these are wear and tear parts. I don't think that they're meant to last 10 years like the warranty. They're just not. These usually last the whole time, but they can pop too. These are wear and tear. If you look at it too long, it'll fail. Thermostats will generally only fail if you've got intermittent contact and this is chattering. I'm going to simulate that for you. All right, so now I've got the common wire off. This is no longer engaged. If I touch the common wire, it goes in. Remove the contacts, comes out. So that's my 24V coil pulling in the high voltage here. You never want to cross these. You'll get a nice light show. So whenever this happens, really, really fast, what will happen is this bobber can get full of water just enough. And here's the crazy part. Let me secure that just a little bit. Here's the crazy part. There's a negative pressure on regular systems a lot of the time. Furnaces have positive pressure, so they're blowing out this drain. The rest of the systems have negative pressure, so they're pulling water backwards That's why there's a trap usually required. Okay, it's actually code, and you can argue that all you want. I'm in Florida. This is code. Having the P-trap is code. No questions asked. It's just a U-bend type piece of PVC somewhere at the unit, a little further away, or outside. And just a side note, I am prepping up my coffee business here. I don't know if you guys are ever interested in coffee. I'm going to have fresh roasted coffee, and I had this where I was going to show somebody. I do roast coffee. I think it's pretty bougie. I donate to local animal shelters. It's groundsoflife.com. And so that's not fully active yet. But if you guys want, you can get on the early riser alerts. I do have some things for sale now, but that will definitely be something I'm doing in the future, a lot of. Now, over here, when this happens, not only can you get arc flash here, and this can get wires hot, it can begin to melt them off here, and then the wire touches something else, and then that's disaster zone. So that's why these are wear and tear parts, because they are doing that. Every time your unit turns on, boom. Turns off, boom. Intermittent water, bad contacts here, ants or something, or burn marks, lots of chatter. Now, I'm not pulling any equipment in at this point. I am powering that capacitor, but this is still not that big of a deal. I can chatter this a little bit. Now, the thermostat stayed good. It didn't have any problems. I could turn this back on. Excuse me. I'll turn this back up and off, and this will disengage. So if you lose the yellow wire going out here, then you will no longer have a connection, and you won't have an outside unit. Now, there's a lot of other reasons for this, but this is one of the biggest causes of compressor failures, thermostats blowing out, fuses popping. This yellow wire is a killer, and it will, in that unit, go between high and low pressure switches and other things, sometimes defrost boards, things like that. So what you would want is definitely to call a professional. Do not do any of this stuff at home. But I hope this is helpful to you guys. And just remember, if that float switch takes water, we'll sim this one more time. It's because it's fun. And I'm going to pour water in there. Boom. That's it. It shut it off. Now we have no power. And just because I like to reiterate my videos, try not to get this thing to fall over on me. Okay, we got all that water in there holding the bobber up. We're still out. I pour that out, and look at that. It's upright, and the bobber is down, and now we've got a thermostat. Okay, super cool. Hope this is helpful. Drop a link in the comments, and if you guys want, you can go to, and I'm trying to get on my TikTok shop, but I don't think it's going to work, but you guys can click the link in my bio and get a filter puller that is amazing. I'm working with the inventor on that one, and I'm going to push that product. It's on Amazon. Go check it out, guys. See you on the next one.